Hello, my dear student of secondary scientific class. We are passing through special moments that we are obliged to broadcast our lessons online, as you know. So we are going to see the last part of Unit 3, Budding Scientist. So please go through reading and writing on page 89 on your book, here, as you see. So our lesson gonna be about an experiment, scientific experiment done to balloons and charts. So here we have in this page 89, these two pictures of figures, figure 1 and figure 2. So we're gonna see two balloons separated or pulled apart from each other. So figure 1, two balloons rubbed against a woolen sleeve. Woolen sleeve, it means the one that you wear here at the end of near to your hand. This is sleeve. Rubbed, repel each other. So go far from each other. Could you tell if the charge is positive or negative? So if the balloons go away from each other, they are charged positively or negatively. We're gonna see this later. So also we have figure 2 here. A glass rod, rubbed glass rod, it's the one that you see here, stick here. Rod rubbed with silk acquires a positive charge. If the balloons are attracted to the rod, what does this mean? So here the same balloons, we put this rod between them, they are attracted to to this rod. So what does it mean? Here we're gonna find the result at the end after reading the text. In paragraph, they said read the paragraphs 1 and 2 below and check your answer to the questions in caption 1 above. Then discuss the following question. Here they ask us if does illustration, picture or figure 1 help you to understand paragraph 1, we're gonna read it, and why. Have you used the knowledge you have acquired in other subjects like math, physics and so on to understand what the paragraph are about? Explain. Can you answer a question included in the caption attached to the figure 2 above? Does the author answer the question in the text at this stage? So let's read the text carefully, then we'll answer the question. We can remove great number of mobile electrons from certain material, leaving an excess of protons. We can remove great number of mobile electrons from certain materials, leaving an excess of protons. This produces a positive charge on the materials. If a given material picks up an excess of electrons from some other object, a negative charge is produced. The charges, positive or negative, are given the name of static electricity. This is the name that the balloons take. The electricity that the balloons take, call them static electricity, whether it's positive or negative. We can perform a number of experiments with this kind of electricity. Our first experiment illustrates the fact that unlike electrical charges are attracted to each other. So we stop here. Unlike electrical charges are attracted to each other. So if the balloon are positive and the other is negative, so they attract to go to each other. So unlike electric charges are attracted to each other. If this positive and the other negative, they attract. And like charges are repelled by each other. If we have positive, they go away. If we have negative charge, they go away. Just if they are positive and negative, they attract to each other. Plus, minus attract to each other. Suspend two balloons by equal length of thread from the thumbtack fastened to the top of an open doorway, for example. Let's see figure 1. They see it here, as you see here. In figure 1, there are two balloons fastened with thumbtack to the doorway. For example, here there is a string here, and there is thumbtack holding these two balloons. Okay, equal level. Here, what is gonna happen? Let's see. All right, figure 1. Sorry. Here, rub each balloon on a woolen coat sleeve. It means woolen coat, something you wear, especially in winter, contains this kind of clothes sleeve. This will charge both balloons the same way. Note that they repel each other. For example, because they take the same, either positive or negative. But we do not know whether the charge they carry is positive or negative. This is very important. If we rub the balloon on a woolen sleeve, coat sleeve, of course they take either negative charge or positive charge. We don't know. How can we know? Alright, let's carry on with the second paragraph that we discovered this now. Now rub a glass rod. It's a stick of glass with silk. Means kind of fabric. When glass is rubbed with silk, it acquires positive charge. This is stable and we are sure about it. So acquires positive charge. Place the glass rod between the balloons, as we saw in figure 2. If the balloons are attracted to the rod, they are negatively charged, because unlike charges attract each other. Because of the rod, this rod is positive, sure positive. If the balloons go through it, it means they are positive. If the balloons move farther apart, they are positively charged, because like charges repel each other. If they go far from each other, it means sure the balloons are positive. If a balloon is rubbed and then placed on a woolen coat sleeve, it sticks to the wall. Wall is not charged, it's neutral. This happens because there is always an attraction between charged object, like the balloon, and uncharged object, such as the wall or a ruler or a pencil. We do it usually. When a negatively charged balloon is brought up to an uncharged wall, figure 3 always, we are here, the electrons move to the opposite side on the balloon. There is an attraction between the balloon and the positive charge. On the near side of the wall, on the other hand, if a balloon is positively charged, it attracts electrons, as we saw here. The electrons will rush over the edge of the wall nearest the balloon, and the balloon will stick to the wall. As you see here, balloon is positively charged. When we put it on the wall or roller or something neutral, not charged, they attract just the positive. If it is positive, they attract just the negative. And by this one, positive charge, negative charge, of course, they attract to each other. Okay, here we have we did last year some experiment in class, as you see here. So two balloons here, we rub them, they attract to each other, means they are positively or negatively charged because they attract to each other. Let's see the picture, second picture here. And finally we do the glass rod here, that is always positive when it is charged. So the balloons are going repelled apart from each other, means this is positive, this is negative. The balloons are charged negative. If the balloons come the road glass means they are positively charged. Here they are negatively charged because they go away from the glass rod. Alright? Okay, that's it. Okay, I have an experiment here that will explain more.
Hi, it's Mr. Anderson, and this is AP Physics Essentials 007. It's on positive and negative charges. Imagine I take a balloon that doesn't have a charge and I rub it on my head. I'm now giving it a charge, so I can move it up to something neutral, like a wall, and if I let it go, it'll just stay there. Now imagine if I take another balloon and I charge that in a similar manner. It should have the same charge as the balloon. And so if I hold it up next to it and let it go, what's going to happen? It'll actually be repelled by that object.
Because this is like charge, the same charge.
Types of charges, and we call those positive and negative charges. And so an electric charge can be positive or negative. If we have a neutral object, it's going to have an equal amount of each of those different charges. But if it's a charged object, like a balloon, then it's going to have differences in the number of electric charges that it has. If it's a negatively charged object, it's going to have more of the negative charges. And if it's a positively charged object, it's going to have more of the positives. Now let's say I bring two objects next to each other that have different charges. What's going to happen? There will be an attractive force between the two. But if we take two objects that have the same charge and bring them next to each other, that could be both positive or both negative, they're going to repel each other. Now, why did the balloon stick to the wall if the wall didn't have a charge? I hadn't done anything to it. Well, if you move a charge up to a neutral object, what it can do is it can polarize that object. It can move some of the charges to one end, and what it does is create a somewhat charged object. So an electric charge can either be positive or negative. And so if we're looking at a neutral object, how many of those charges are we going to have in that object? An equal amount of each. Now let's say we take a charged object like that balloon. What are we going to have? We're going to have more of a positive charge if it's a positively charged object, or if it's a negatively charged object, we're going to have more of the negative charges inside it. Now, let's say we take two neutral objects, so two balloons that we haven't charged, and we move them right next to each other. What's going to happen if we let them go? Nothing's going to happen. There's going to be no attraction between the two because the charges are equally distributed. Let's say we take two objects that have opposite charge. So the one on the left has a negative charge, one on the right is going to have a positive charge. If I let these go, what's going to happen? There'll be an attractive force between the two. Opposites attract. Let's say we take two objects have the same charge and move them next to each other. In this case, they both have negative charges. What will happen when I let go? They're going to push away from each other. Same thing if they're both positive. If I let them go, they're going to move away from each other. Now let's say we take a charged object, so that's the one on the left, and then we have a neutral object, that's going to be the one on the right. Watch carefully what happens as these two come together. So as I move the charged object towards the neutral object, what it's doing is it's polarizing those charges. It's moving the negative charges farther away. Why? Because they're being repelled by these negative charges. The positive charges are moving towards it, and so now there's an attraction between this polarized what used to be neutral object. And so PHET makes a wonderful simulation that kind of walks you through that. So what we've got, here's the address down below, and I'll put a link in the video description as well. So what I'm going to do is take a balloon, and I can move that balloon around, and if I let it go, it just stays where it is. But let's say I want to charge it, what I can do is I can rub it on a sweater like this, and now I'm applying a charge to that balloon, so when I let it go, it's going to go right over to the sweater. And so if we move it next to the wall and let it go, it'll stay there, but if I get it close to the sweater, then it's going to be attracted. And so let's reset this whole thing and look at the charges now. So you can see that all these objects are now neutral. They have equal amounts of charge. But as I rub it on the sweater, what I'm really doing is I'm pulling those negative charges off the sweater, and now they're on the balloon. So now that balloon is a negatively charged object, and the sweater is a positively charged object. So if I let it go, it moves right next to it. Now, watch what happens when I move it next to the wall. You can see it's polarizing this neutral object of the wall. So I'm not transferring charges, but if I move it next to it, it's attracted. Let's get two balloons now and remove the wall. So let me add negative charges on this green balloon right here. And now let me add more negative charges on this yellow balloon. What's going to happen? Well, as I move that balloon next to the other balloon, these are like charges. And so you can see that they're repelling each other, and it eventually would like to go back to that sweater. Okay, so did you learn the following? to explain a two-charge model of electric charge. Again, if it's a neutral object, we're going to have equal amounts of each of those two different charges. Did you learn that the distribution of those charges tells us if the object is going to be positively charged or negatively? You can see this would be a negatively charged object here. And then finally, did you learn to explain how the polarization of electric charge or separation of that charge in a neutral object can lead to an attraction? So we have an attractive force here between a charged balloon and what used to be a neutral wall. I hope so, and I hope that was helpful.
Thank you very much. Alright, so this is an experiment. Explained how the balloons charged, and one it repels, one attract to each other. Also there is some beautiful experiments.
That includes the one on how to make your own electroscope.
Okay, let's try this one better. For example, as you see charts how they play, they work. Hovering plate means the one that fly. Hovering plate. Can go. This is a can, and they say they can go. We might try it at home. Stick around. Straw, cloth, bubbles motion. We call this bubble trouble. Amazing. And let's see the last one, dancing balls. Covered with aluminium foil. Alright, this is a static charge, so what can do to things? Water blender and so on. There are many experiments, amazing experiments. You can try it at home safely. Alright, thank you very much. We reached the final of this part, reading and writing of unit 3, budding scientist. Next time we're gonna pass to the new or the last unit, unit 4. No man is an island. See you then. Thank you very much and